Today we have David Wagner speaking to us about object capabilities for security. David is a professor at Berkeley, and he's also quite famous and skilled for attacking various systems. I've been through 3 security reviews with David, and I've learned more by being attacked by David and by watching him attack than probably any other single experience, my own education on security. He's also found the best vulnerabilities found to date in AES. He led the effort to attack voting systems and document their vulnerabilities. And today, he's going to present his work on the defense side for all the rest of us to attack. So here's David.
All right, thanks. Great. So I want to tell you a little today about an approach to building secure systems that I find exciting. Let me make one quick correction to what Mark mentioned. I'm not going to be telling you my ideas. Almost everything I'm going to show you in this talk is ideas I've learned from other folks, many of whom are here in this room. So all credit to them. In particular, I want to tell you about an idea, a theme, a community that's coalesced around the term object capabilities. There's a small community of folks who've been working on a set of ideas that I think aren't as widely known as maybe they ought to be known. And so that's what I want to show you in this talk. Okay? And please feel free to interrupt me with questions. Stop me at any time. I'd love to have this be an interactive process. Okay, so let me start off with a motivating example. I want to show you an example of a very powerful program on your computer, installed on your very own computer. You probably know many people who use this program. This is an extremely powerful program. It has the ability to delete all of your files. It has the ability to misuse your credit card number and place all sorts of e-commerce orders you wouldn't have liked. It has the ability to trawl your email and post the juicy excerpts on some news group. What is this program? Well, it's solitaire, but it's not just solitaire. It's every program you run. Every program you run has all of these powers. Okay? Every program you run has the power to delete all your files, has the power to ruin your life, has the power to do all sorts of nasty things to the files in your computer. And why is that? Well, let me come back to why in a minute. This is a problem for security. Reason you should be concerned about this is that this is one of the contributing factors that makes viruses and worms so devastating. Because if solitaire is corrupted by a virus or a worm, then it can do an enormous amount of damage. If the creator of solitaire was malicious, he could have hidden a backdoor in there that could do all sorts of damage. Now, I have no reason to think that solitaire does any of those things. But this is a powerful program, and as we know, power corrupts. In particular, this is, I would claim this as one of the major risk factors that contributes to the security problem we face today. And if you've read the old literature on computer security, you'll recognize this as a violation of the principle of least privilege. Back in the 70s, Salzer and Schroeder wrote about a set of principles. One of the principles they recommended was the principle of least privilege. Programs should be given the privileges they need that they legitimately need to accomplish their purpose and nothing more. What does solitaire legitimately need to enable you to play a game with it? Well, it needs the ability to render, to paint to its window. It needs the ability to receive mouse actions that are directed at that window. But it doesn't need the ability to write to every file on your file system. But it gets that anyway. Okay? All right. So the solution to this seems like it should be obvious. Rather than granting solitaire the ability to ruin your life, it would be much nicer if Solitaire and every other program you ran received only the rights and privileges it needed to do the useful work and not all of this excess rights. And the purpose of object capabilities, one of the things about object capabilities I find exciting, is that they can help make that task easier. Okay, so in this talk, I'm going to talk a lot about privilege. I'm going to talk about the principle of least privilege and how we can accomplish that. I'm going to talk about how we can enable and help programmers to reason about privilege and the privileges their programs use. And of course, I'm going to talk about object capabilities, which are intended to help accomplish all of those goals. So one of the greatest enemies of least privilege is an approach that I'll call ambient authority. Now, let me warn you up front. I want to share with you the ideas that I've learned from the capabilities community. They've developed a whole set of terms and slogans and names that might not be familiar to you. So one of the things I'll be doing as I go through this talk is exposing you to those names and the concepts. And here's one of them, ambient authority. I'm going to explain in a minute what that means. Please stop me if I forget to explain any of these jargon. Okay, so let's take an example. Let's imagine you want to copy a file. You want to copy foo.txt to bar.txt. Well, how do you do that in a typical Unix system? You run that command up there. You run the CP program, and you pass it 2 strings on the command line. Now, when your shell runs the CP program, when the CP process is executing, that's going to run with all of your privileges. It's going to run under your user ID. It's going to have the power to open and modify and read and write all the files that you have the power to. Okay, so it receives all of your authority. And it has to. If you think about how the CP program works, the interface to this program, really there's no other option. There's no other way it could work. Because we're passing 2 strings to this program. And the program has to be able to take those strings, interpret them as file names, open those 2 files. The operating system better allow those open system calls to succeed. And to ensure that that happens, that means, well, look, I might want to be able to copy any file on the system anywhere and any other file on the system that I have the right to. So it sounds like CP has to have the ability to open any file that I have the right to open, that I have the right to read and write to. So it sounds like it follows almost logically from the specification of what CP is supposed to do, that the operating system has to grant CP all of these powers, all of these extraneous powers, even though this one running instance of CP really only needs to be able to access those 2 files. It's getting a whole lot more than that. Okay? So let's consider another approach, which is somehow analogous to what the capabilities approach is trying for. Let's imagine that instead we copied those files using the cat command. All right? Now I could type this second command into my shell. And what would cat be passed? Cat is passed not to file names, but to file descriptors. Okay? Passed a file descriptor for foo.txt, and it reads the bytes from that, and it passed a file descriptor for bar.txt, and it writes to that. And you can notice that with this interface, now that I've changed the interface in this way, cat no longer needs any authority, no longer needs the operating system to grant it any of my rights and privileges. Because the file descriptors, just having a file descriptor alone gives me the ability to read and write on that file descriptor. So cat doesn't need to be able to open other files on the system. So if only we could structure our systems like this, then we wouldn't need to grant all of our processes all of this excess authority. Okay, so this is an analogy to illustrate what we're going to try and head towards. And by the way, let me introduce you to some more jargon. I've used the word authority, so let me explain what I mean by that. What I mean is authority is the power that a program has or a process has to affect the outside world, okay? To cause side effects in the outside world, to cause the ATM machine to spit out $100 to you, to stamp a hole in that device over there, or maybe to write to a file, okay? And authority is in some sense transitive. Let me distinguish between what we might call permissions and authority. I might have permission to write to a file, okay, because that file's access control list mentions my name and says I'm allowed to write to it. Okay? That'll mean I also have authority to write to that file. But consider the following variant. Suppose that I can talk to Bob. I can't write to the file myself, but I can talk to Bob, and Bob can write to the file, and I can send Bob some message that will cause him to write to that file. Okay? In that case, we'll say that I don't have permission to write to the file directly, but I have authority. I have the authority to write to that file because I can take an action which will cause that file write to happen. Okay? So in some sense, authority is kind of transitive. An ambient authority is authority that's in the air for the taking. It's available for you. It's sitting there waiting to be used even if you didn't explicitly ask for it. Okay? So you can think when the CP process gets instantiated by the operating system, it's like the operating system had this big old bag of rights that it's remembering. It says, with this process, here's a set of all the things, operations it's allowed to do. And when the CP command asks to open a file, the operating system starts rooting through that bag of rights and says, is there anything in there that would justify allowing this open call to succeed? Oh yeah, I found one. Okay, I'm going to let the CP open that file. That's an example of ambient authority. Ambient authority is kind of the global variable of security. Okay. Now, ambient authority is really bad for least privilege. I hope it's clear why this is the case. Ambient authority is really bad for least privilege because by default, your processes get everything, get all the powers. They get the maximum possible power, which means that they get a whole lot more than any particular instance of that process really needs. Okay? So one of the goals of object capabilities is that we're gonna just say no to ambient authority. We're going to try to achieve least privilege through an architecture where processes by default receive no authority, not where processes by default receive all authority. Okay, so to introduce a little bit of more jargon, we could say that ambient authority violates the principle of least authority because the default gives programs authority they don't need. Okay? And you notice that I've switched talking now from the principle of least privilege to the principle of least authority because the principle of least authority is what we really care about. So we call that Polo for short. Okay. Are you okay with the capability jargon so far? All right, so now here's the point. Here's the thing that's exciting about object capabilities, is that capabilities make it easier to achieve the principle of least authority. Our current operating systems do a lousy job of that. My Windows machine, my Linux box, your Macintosh machine, they all violate Polo because they are ambient authority systems. They give every process you run all the authority that your user has. In fact, on a single user machine, that likely means basically all of your files, almost all of the interesting files on there. Okay. Capabilities have the promise to change that because the traditional view says, well, accomplishing principle of least authority is really hard. Capabilities is trying to make this easy, and one of the key ways that it makes it easy is that they make the process of identifying which files you want to operate on also automatically convey with them the authority, the rights you need to be able to operate on those files. So imagine if the CP program, instead of receiving strings, it received some magical entity that not only identified which file you want to operate on. That's what the name foo.txt is supposed to do. It's supposed to help you identify which file you want to operate on. But also that magical entity also gave the CP command the power to read and write to that file. Okay? Well, then that would be great because then we could give the CP command by default when that process starts, we could give it no authority at all. And then in the process of running CP to copy foo.txt and bar.txt, when we pass it those magical entities, it will receive just the minimum it needs. Okay? Well, that magical entity is a capability. A capability both identifies what file we want to operate on and and provides the authority to modify that file. If you have a capability to that file, then you have the right to modify that file. That's all you need. That capability is enough to allow you to act on the file. Okay? So the classic example of a capability, if you're in a Unix world, is a file descriptor. If you have a file descriptor to some file, that's all you need. That's enough for you to modify, to act on that file, no matter what the access control permissions on that file say. Okay? So this has two advantages. Well, first, it means that system administrators don't have to configure complex security policies. We can get fine-grained Polo without requiring system administrators to do a whole lot of work to configure these really detailed access control policies, because just by virtue of the way that users invoke programs causes those programs to receive the least authority they need to do their job. Okay? And we can apply this not just to programs that users run, but we can apply this to software architecture, to the internal interfaces of the programs we build, so that the interface between modules, the module that's being invoked, when it receives not in the capability way, we don't pass a file name telling that module what file we want it to operate on. We pass a capability to that file, and just by virtue of defining the interface in that way, that module receives the authority it needs, and it can be granted, when it starts up, nothing more than what it's going to receive through that interface. Okay? All right. So what's an object capability system? I've been using the words object and capability, so let me define my terms a little bit. In an object capability system, there's only two kinds of things. There are objects, and there are capabilities. An object is, think of like Java, a Java object. It's an entity that has some state and some code. Okay? And it has some public entry points that anyone can invoke. They can send messages to it that will cause execution of some code. And it has some private state that its own code can read and write, but that is not accessible to the outside world. Okay? So the object's a protected domain. And a capability is just an object reference. It's a pointer to, an unforgeable pointer to an object. Okay? And the key feature of an object capability system is that that's all there is. There's just objects and just object references. And moreover, that the only way to obtain authority is by receiving a capability. Okay, so one of the key properties of an object capability system is if you don't have any capabilities, you don't have any authority. You can't affect the outside world. And the only way you can gain the ability to affect the outside world is someone gives you a capability. Okay? And moreover, in an object capability system, all the rights that we care about should be represented by capabilities. Okay? So this means, for instance, that if Alice has a capability to write to some file, and she wants to cooperate with Bob, and she wants Bob to be able to write to that file, all she has to do is just pass that object reference to Bob. And then Bob will have that capability, and Bob will be able to operate on the file as well. Now, what I'm particularly excited about, capabilities are an old idea, but what I find especially exciting today is the possibility for language support to make it easier to build capability systems, to build system in this style. In particular, type-safe object-oriented languages seem to be just perfect for the capability style. The reason is, if we think of a language like Java, Java is already very close to an object capability system. Java objects can be our objects. It's got references which are type-safe, unforgeable object references. They are our capabilities. The language itself is very close to what we want. We just have to be a little careful to make sure the one way that Java violates the object capability paradigm is that it provides the class libraries, for instance, provide methods that allow you to write to a file even if you don't have a capability. Okay, so that violates the capability rules. So but the language itself, if we exclude the libraries is pretty close to what we want. And notice that the key bit here is the type safety and the notion of code and state in an object-oriented language. We don't care about things like polymorphism or inheritance. Those may all be good features, may be nice features, but they're not necessary for the object capability way. Okay. And one of the key things here is that by working in a type-safe language, the language type-checking rules are what ensure that objects are tamper-resistant, what provide the protected domain. Question?
It seems that there's an essential aspect missing from Java, which is that Java has static fields.
Thank you. Yes. So the question was, the observation was that one problem with Java is that Java has static fields. They're effectively global variables, and that's right. That violates the capability rules. If you have a mutable static field, then that's provides authority. And if I have a static field that can hold a capability, then that's even worse. That violates the rule that when I write code, when I instantiate a new object, by default it shouldn't have access to any capabilities. So the answer to that is that you have to excise, roughly speaking, excise static fields from the Java language if you want the Java language to be an object capability-like system.
And it seems to me like you also you can't just excise the mutable static fields. Even if you have a static field that's immutable, that potentially allows people to get information that they shouldn't have. Even if they can't affect something they shouldn't affect, they can still get something they shouldn't have.
Excellent observation. The observation was that even if we think only about immutable static fields, then they provide all of your code access to whatever information is held in there. If that's a crypto key or some secrets, then that might leak secrets. And you're right, that's an issue. And I should warn you of one of my biases. My own bias is that I tend to think primarily about integrity issues. I find confidentiality very challenging to reason about because of issues like covert channels. It's very hard to come up with sound styles of reasoning for confidentiality. So for this talk, let me focus only on integrity. But you're absolutely right to identify that. The key thing, you notice that we're talking about static fields is, this drives into the scoping, it's the scoping rules in the language which is what gives us the least privilege and what gives us no ambient authority. Because objects only have access to capabilities that are in scope. If we're in a language where what's in scope, where the universal default global scope provides no authority, then newly constructed objects have no authority at all. Now, thank you for raising these issues about Java. Your check is in the mail because this transitions very nicely to the next thing I want to talk about. I want to tell you a little bit about some ongoing work that's going on in my research group, in particular being led by Adrian Mettler and others, here to build a subset of Java, a new programming language that we call Joe-E. It's basically a refinement of Java, what Java should have looked like if it was going to be built in the object capability way. Okay? It turns out that there's not, as I mentioned, the Java language is already pretty close to what we need. There are a couple of things we need to eliminate from the language, such as static fields, native methods, the libraries have to be subsetted. They're a major issue. Also, multi-threading and class loaders pose a number of challenges. In the current iteration of the language, Joe-E is a single-threaded, single class loader subset of Java. I'm not going to tell you too much more about the details of Joe-E. I'd love to tell you more after the talk. One of the key things about Joe-E is that we think that an object capability language can be pretty familiar to programmers. It doesn't have to be a major learning curve. I think if you were programming in Joe-E, you might find it a little unusual to program in the capability style, but the language itself would look very familiar to you if you're a Java programmer. We think Joe-E is a promising basis for building really secure systems, for building extensible systems where you can allow people to put in plugins where you can limit the amount of authority those plugins will receive. You can envision all sorts of ways to structure your systems, and I encourage you to think about how you could improve the security of your systems and help them to achieve the principle of least privilege by structuring your systems and building them in an object capability style. For instance, I'll give you one example to get you thinking. You could imagine a Gmail where after the user has logged in, gone past the login screen, all the code that runs from there on, imagine if that code was handed a capability to the user's mailbox and a capability to the session, but not to anything else. In particular, not a capability to any other user's mailboxes. Then you could have an incredibly complex and rich code that handles the user interface. And just by virtue of the capability language, you could get some confidence, some assurance that one user's actions won't disrupt someone else's mailbox. OK. So another topic, I think, at this point, maybe I move on to a second part of the talk. I'll tell you a little bit about how to reason about authority. If you're going to build programs in this way, one of our goals for Joey was to make it easy to do code reviews for security of these kind of systems and make it easy for programmers who are implementing these systems to think about the flow of capabilities, of privileges throughout their programs. So to give you some examples, suppose I have a really key, important data field in my program, account balance or something like that, and I want to know what are all the places in the code that might be able to write to that piece of data. Okay, that's a kind of query that you might like to answer during a code review. Or another example of kind of reasoning you might like to do in a code review is, I've got a chunk of code I'm reviewing right now. What is the maximum amount of authority that code might be able to receive? That will help me understand how much damage it might be able to do if it goes awry. Okay? So those are some kinds of reasoning that I think are really important and that object capability languages are intended to help you with. And just a little bit of notation. Here I'm drawing each object. Here's an object Alice, an object Bob, and Alice has a reference to Bob. She has a capability to Bob. Okay. Now, one of the key challenges in reasoning about large systems is how to make this scale, because we can't keep all the code in our head at one time. That's just not feasible. So in the programming languages world, PL folks have done a lot of work on what they call modular reasoning. And the idea is that we want to look at one module at a time and understand just that module and how it interacts with the rest of the system. And in this way, by doing only local reasoning, try to infer some global properties about the system. Is it correct? So the most naive way you could imagine doing this is we could say, well, let's look at the code of Alice. And just by looking at the code of Alice, not any of the other code in the system, try to determine whether the code of Alice is correct. Okay? So when I say not by looking at any of the rest of the system, what that means, we have to assume that all of the clients of Alice are potentially malicious. They might behave in arbitrary ways because we haven't looked at their code, so we can't characterize how they might behave. And all of the services that Alice calls also will presume malicious. We can't assume anything about them because we haven't looked at their code. The only thing we can assume is that that other code has to follow the capability rules because it's written in a capability language. Okay? And then you could imagine trying to reason about Alice, draw a perimeter around Alice, and just by looking inside that red perimeter, determine whether the code of Alice appears to do what it's supposed to, appears to be correct. Okay? So if you're a security person, you say, well, we draw a security perimeter, we assume everything outside that perimeter is malicious, and what can we conclude? If you're a programming languages person, you say, well, we look at the code Alice, and we quantify over all the possible instantiations of the rest of the system, and we try to say what properties can we conclude. Now, the problem with this kind of reason, this naive version that I showed you here, is this doesn't work. It doesn't work very well. Because in practice, you find that you can never convince yourself that Alice is correct, or rarely can you convince yourself that Alice is correct just by looking at the code of Alice. Because quite frequently, Alice provides service to some of her clients, but she in turn relies upon the services provided by other objects or modules that she invokes. So this is too naive. So, but we can fix that. We can, there are patterns of reasoning that allow you to take that into account. This brings me to the topic of trust and vulnerability and reliance in a security system. here in this diagram, Alice is a client and Bob and Charlie. She invokes them to use their services. Maybe Bob's a hash table and Charlie's something else. And you can imagine that in some cases, Alice might decide that she's willing to trust Bob and Charlie. And that's a peculiar way. Be careful what that word trust means. That's a funny way of saying that Bob's willing to accept, she's willing to render herself vulnerable to failures or misbehavior of Bob and Charlie. She's willing to rely on them. She has faith that they'll do the right thing. And if they don't do the right thing, then she can be totally screwed. Okay? So this is a fairly common pattern you might find in a system. How can we reason about that? Well, one way you could reason about that is we could say, let's reason about Alice. Let's look at the code of Alice. Looking just at the code of Alice and looking at the contract that Bob and Charlie export, and just assuming that Bob and Charlie correctly implement that contract, but not making any assumptions about Alice's clients, can we convince ourselves that Alice is correct? Okay? And once we've convinced ourselves that Alice is correct, then we're entitled, other people are entitled to rely upon her. Okay? So we might have started by verifying that Bob and Charlie were correct, and then once we verified that Bob and Charlie are correct, then we verify that Alice is correct, and we're proceed in this way up the call chain. So this brings me now to the notion of defensive consistency, because that is also a little too naive. In practice, it's often the case that Alice has multiple clients. And Alice, typically, Alice will export a contract. She has some preconditions. If the client satisfies those preconditions, then she is promising to provide some kind of useful service to them. Now, we could say that Alice must provide useful service to all of her clients, but that seems like too strong of a requirement, because what if one of her clients violates the preconditions? What if one of her clients does not follow the contract? Then in that case, we ought to release Alice from her obligations. Okay? But this is a little challenging because, in this case, we'd like to know that if Zach is malicious, but Yolanda is honest and is relying upon Alice, that Yolanda can still count on Alice to provide Yolanda with useful service. But we'd also like to say that since Zach violated the contract, Alice doesn't have any obligation to provide Zach with any useful service. Okay? So this is the notion of defensive consistency. If Zach misbehaves, then we release Alice from the obligation to provide correct service to Zach, but she must still provide correct service to Yolanda. Okay? Defensively consistent services are often more useful. Okay? If I want to use some other service, I don't want to have to characterize all the other clients of that service to know whether they're malicious or not. I'd like to know that as long as I use that service correctly, that I'll get useful service, even if the other users of it are malicious. Okay? So defensive consistency enables a kind of modular reasoning. Because in this reasoning, the way this reasoning works is that we look at the code of Alice, we look at the contracts of Bob and Charlie, we assume that Bob and Charlie follow their contracts. And then it's our proof obligation when looking at the code of Alice to verify that if Yolanda meets the preconditions, then no matter how Zach behaves, quantifying over all possible instantiations of Zach, that Alice will still provide correct service to Yolanda. Okay? All right, so this is an example of modular reasoning, because you notice to do this kind of reasoning, if the system was constructed thoughtfully, was done right, we only have to look at the code of Alice to convince ourselves that Alice is defensively consistent, and the contracts that Bob and Charlie, but not the code of Bob and Charlie, not the code of Zach. Okay? So we've constrained the scope of the code we need to investigate. So let me give you an example to help you understand how this might play out in a concrete situation. This is a toy example. Imagine that, for instance, we've constructed a system where we want to build a append-only log. Okay? In a capability system, the way you do that is you build a logger component. This is an object that has a reference to the actual log data. And the logger component, the code of the logger component is written only to append, not to overwrite existing log entries. So to verify that this really does provide a append-only log, what code in the system do you have to look at? All you have to do is you have to make sure that the logger has the only reference to this underlying private data. We better make sure the logger creates that reference and keeps it closely held, and that the code of logger only appends. Okay? So you notice we've only had to look at the code of the logger. Let's compare that to if you'd written this system in some language like C, not memory safe, not object capability style. What would you have to do if you wanted to really be confident that this is an append-only log? Imagine there's 1 million lines of C code. You're hosed. You have no hope. Because for all you know, there could be some other C code somewhere else that concocts up a pointer into the middle of this data structure and starts overwriting it. And that could happen deliberately, maliciously, or it might happen accidentally. Maybe there's just some array out of bounds error or a buffer overrun bug elsewhere in the code. Okay, so in a system written in C, one giant C program, you'd never have any hope of really being confident that this is an append-only log, because it's just not feasible to go examine all of the C code in the system and convince yourself that it will never cons up a pointer into the middle of this data structure and start overwriting log entries. Whereas in an object capability system, verifying this is simple. And that's good. We would like simple tasks to be simple. Okay, so to jump ahead to the end, summarize, what are the key messages I want you to take away from this? I think one of the things that makes capabilities exciting is that they seem to make principle of least authority easy. In particular, principle of least authority seems to come from good object-oriented design and good design of your class hierarchy. And the second thing I wanted you to take away was the capabilities can enable modular reasoning. They can make it easier to reason about your code. They can make it easier to do code review. They can make it easier to gain confidence that your system will work the way you want if your system is constructed thoughtfully in a way that's amenable to this kind of analysis. Okay? So, personal view here, object capabilities, I think, are a really intriguing set of ideas. You've now learned enough that you can form your own judgment. I encourage you to look for opportunities in the systems you build to apply these ideas. Look for ways to minimize ambient authority. Look for ways to combine designation with authority. For instance, don't pass file names, pass a reference to Java lang file. You can look for ways to write your code in a way that enable modular reasoning and make it easy to verify your code is correct just by looking at local instances of this. You don't have to use Joey. You don't have to use an object capability language to benefit from all of these, although it helps. Okay, so if you're interested in any of this, I'll leave up a few references here for more reading. You've got some of the experts right here in Google. Go talk to them. Thank you for your attention.
How do you deal with sending capabilities over a network? Like, let's say in some case you want to send a lot of data over the network, but once you send the data over the network, then you kind of lose the guarantees of the language because whatever is processing it on the other end might be malicious. So how do you deal with things like that?
Yes, okay, so this gets a whole lot more interesting when you talk about distributed systems. Let's see what I can say about this. I'm not an expert in distributed systems, so I hope I don't mangle this. Mark and Tyler, who are sitting near you, can probably give you a better answer to this question. You can build distributed systems in the capability style. What you need is an RMI-like layer that is built to support capability-like systems. Okay? So for instance, if I'm an object sitting on my machine and there's an object sitting on your machine, and I want to invoke your object, then I need a capability to your object. I need a reference to your object. And one of the things that RMI protocol can provide is it can provide me with what looks to me like a reference to your object, and what is actually implemented as a proxy object that's in my address space that I can invoke. And when I invoke, that and then in turn causes messages to be sent over this secure RMI layer, which then cause to be invoked on your object. Now, what properties can I count on? The properties I can count on in a distributed system are a little bit less than what I could count on if I knew that my entire system was hosted on a local capability machine. Because if I don't trust your machine, I don't know whether the code on the far side of that network link is going to respect the capability rules. But what my communication protocol can do is it can enforce some of those capability rules. Okay? For instance, I can enforce that you can only invoke one of my objects if you have a capability to it. Meaning if I've actually given you a capability and my RMI system has turned that into a cryptographic secret, which is the representative you hold as your representation of that capability. You can't just send me an address space and tell a pointer into my middle of my address space and cause my code to jump into the middle of that address you constructed. So I think that I have probably mangled some of the subtleties here, but it is possible to build pretty exciting distributed systems. If you want to take a look at one example, you can look at Tyler's Waterken system, where capabilities at the language layer is a system that translates them into URLs, so you can invoke them by HTTP. The URL has a cryptographic secret, an unguessable secret in there, which enforces the unguessability, the unforgeability of capabilities.
Tyler, who? Who's Tyler? Oh, you okay? Great.
Let me just, before I hand the mic off to the next question, let me just mention I'm going to be inviting Tyler in to give a tech talk probably early January on the Waterken server.
So if capabilities are so great, then how come they haven't revolutionized the world 20 years ago?
Yeah, it's a hard question. You know, there's this famous quote that says, I think it's from Butler Lamson, the capabilities are the way of the future. They always have been. They always will be. I think I have a couple of potential answers to that. I can't say with confidence until we successfully built enormous systems in this style. Historically, I think there are a couple of challenges. Capabilities came out of desire, again, the same motivation. Gee, principal-based privilege would be great. We can do a better job of principal-based privilege if we have fine-grained access control. But unfortunately, many of the fine-grained access control systems at the time required system administrators to configure complex policies. What are all the set of files you should be able to write to? What are all the set of network ports you can open? And that just isn't reasonable. It's not practical. And so fine-grained access control systems got a really bad name, rightly so, because they were impossible to administer. So I think one of the things that's new about capabilities is that they're in some sense self-administering. I think the other thing that makes them exciting now is that now we have a programming language technology which can make these capabilities easy. The capabilities look like you're just programming in a type-safe programming language, and the language's type system enforces the security checks for you. So I think there may be an opportunity now for this idea, but it's completely fair and right to be skeptical.
David, could you say just a little bit about what the current status of Joe E is? I've talked to some customers who might be interested in actually being able to run untrusted code within a server that I'm building, and I wonder how many of the libraries are available, how much of the taming have you done, all of that kind of stuff.
Yeah, so I'd love to find some users for Joe E. It's somewhere in an alpha, research prototype state right now. It's surprisingly mature for a research project. And Adrian's done some great work on it. So what we have right now is we have a language specification. We've built a Eclipse plugin that will verify that your code follows the restrictions of the language. The primary challenge right now that we need to do a lot better on is the library taming. We need to do a better job of putting in place policies that say these libraries are consistent with the capability style, these libraries are not, and to have our plugin enforce that for you, so it'll give you a warning message or an error if you're using one of the disallowed libraries. We're actively working on that. We've got a good handle on that, but it's not done yet. So right now, we've got a little bit of implementation experience. We've got one user. The water can system I mentioned is built partially in Joey, so we've got over 10,000 lines of Joey code there. And one of the students who's here, Matt Finifter, I'm happy to introduce you to him, has been gaining some experience taking legacy Java code that wasn't written in a capability style and experimenting to see what does it take to turn that, to Joey-ize the Java, to turn that into a capability style. Now, that's not the way that I recommend to use capabilities. That's not what Joey was designed for, but we're trying that to see, to get a handle on how unnatural a programming paradigm, does this feel unnatural? Does it feel strange that you lose expressivity? And I guess so the bottom line is we'd love to have users, and if we have users, we'd love to support you and provide you with what you need so that it can be useful to you.
Hi. It sounds like Joey doesn't have multi-threading. In fact, you said Joey doesn't have multi-threading. Do you have it turned off because thread safety is not easy, because there are gaping covert channels in today's architectures? Is there anything else on top of that you have it turned off for?
Oh man, thread safety is a can of worms.
Yeah.
The Java threading model wasn't designed with the capability style in mind. It makes a lot of it invalidates a lot of the assumptions we're currently making. So for instance, one of the ways that we use Joey right now is that we have some infrastructure that allow you to verify that classes are immutable. They're semantically, transitively, deeply immutable. That once they're constructed, the value can't change. Well, it turns out there's a whole set of intricacies in enabling you to build a practical and yet sound verifier that if it says that class is immutable means it really is. And one of the ways that this is challenging, I think that threads would raise a set of issues here, which I haven't begun to think about, is what happens if some other thread modifies tries to modify the state of that object in the middle. So we haven't yet begun to think about thread safety at all. There's a set of issues there. I'll give you another example of a tricky issue there. Monitor locks in Java are effectively they're ambient available. So you'd have to think carefully about what kind of ambient authority they provide. I can acquire a lock on any other class I want, I believe. And that might invalidate all sorts of assumptions. That doesn't sound like the capability way.
So the biggest hurdle of having multiple threads is that it raises lots of non-determinism issues. And right now, we actually have some determinism guarantees that we're able to guarantee with Joey, or we believe that we can guarantee with Joey. And those all go out the window if you have concurrent modification for multiple different threads that have access to the same object.
So are you thinking about adding event loop concurrency instead? Like as in ease VATs and stuff like that?
That would be great. First step is to get a single-threaded Joey that's useful and production quality. It's a great research question.
Could you talk a little bit about dependency injection and the differences from the capability style?
No, probably not, because I don't know enough about dependency injection. Can anyone else talk about that?
I can say a bit. I don't really understand dependency injection yet, but one of the things that's interesting is that what dependency injection is trying to achieve seems very similar to what capabilities are trying to achieve, which is a dependency, as dependency injection seems to define it, is basically ambient access to some state or authority to the outside world. And if you make all such dependencies things that need to be explicitly provided, essentially you're programming the capability style. One way to think about Joey from a dependency injection point of view is that it enforces that all dependencies must be injected.
Hi. I was actually going to ask the same question about this is an old idea, why hasn't it caught on sooner? And in fact, there was some language-based work done on this back in the early 1980s in RSRE in the UK on something called Flex, the Flex architecture, which used Algol 68 and a kind of lexical closure approach to implementing abstract data types and so on. So that's really quite interesting. That led into the 1015 and F architectural neutral distribution format. So let me ask a different question, which is, I was a bit concerned that your model, as you defined the object capability model, you said that the property is that if you have a capability, you can give it to someone else. And that doesn't seem like a good idea. You might want to give someone a capability, but not give them the right to pass it on to someone else. And I actually found a paper just now which said that if you have that an unmodified capability machine with that property violates the star property, which is one of these security things about information flow. So I wondered if you had a view on that.
Great. I'm glad you asked this question because this is one of the most frequent ones we get. Let me see if I can clear it up. OK, so let me state first a little more precisely what the capability model is. If I have a capability to Alice, then I can give her the capabilities I have in the capability model.
Yeah.
Okay, no restrictions on that. Why is that a reasonable thing? Well, the slogan that I'll use to justify that is, don't try to prohibit what you can't prevent. Okay? So in particular, if I have a capability to Alice, I have a communication channel with her. I can talk to her. Yeah. We can exchange messages. If we can exchange messages, if I have a communication channel with her, and if I want to give her some capability, then gee, even if you try to prevent me, you're not going to be able to prevent me because I can always proxy for her. I can always just wait for her to tell me what she would have wanted to do with the capability, and she just tells me to do it instead, and I do it on her behalf. Okay? So you can't prevent that. So preventing it wouldn't provide any stronger security properties, wouldn't enable you to rule out misbehavior that you can't do in the object capability system. So that's my primary answer. Now we can talk about the star principle offline. I think that my understanding is there's some flaws in that the argument, and that in fact this is not a correct conclusion. But you know what? I don't want to get into that because I'm going to tell you in my Joey mindset, I mentioned I'm focused on integrity, not on confidentiality. Yeah. And reasoning about confidentiality is incredibly hard. I have no idea how to prevent covert channels, how to prevent any two objects from communicating with each other if they're running on the same machine or in the same JVM. There's so many covert channels they can use wall banging attacks that I have no clue how to solve that problem. So in Joey, the philosophy is Joey is not going to help you reason about confidentiality or covert channels. We assume we reason only about side effects. We don't reason about knowledge. Okay? So in particular, we're trying to enable a kind of a conservative bounds on the behavior of our program. And that part of the way that reasoning works is if there's some secret knowledge, some secret bits that would enable you to do something, then the kind of our style of reasoning says, we assume you got those bits. Okay, you guessed them luckily, or someone with a covert channel communicated them to you. So that's just not a style. If your system relies upon secret knowledge for its security, then the Joey style of capability reasoning is not going to help you verify that it's secure. You'll have to use some other kind of reasoning.
Okay.
Does that answer your question?
Yeah, I guess what you were saying about the passing on the capability thing seems to relate to this trust issue, because what you were saying was if I have a capability, if I'm, there's no difference between me passing it on to somebody else and me kind of betraying the trust that's been given to me and giving me the capability in the first place, because I cannot act on behalf of that other person, and I'm not entirely sure about that. It seems that, maybe but it does seem to come down to a breach of trust in some way.
I agree that there are differences there. I don't want to suggest they're exactly equivalent. There are performance differences. There are differences in reliability. But my argument is those differences are not significant enough to provide a foundation for a security case.
Yeah, it's an interesting point. Anyway, thank you.
You haven't said anything about the revocation of capabilities. So if you give someone a capability, do you later have the right to revoke that capability and revoke only the right you gave them, not rights that others gave them?
Yep. Great question. Yeah, so one of the standard criticisms of the capability model is it doesn't provide any answer about revocation, at least doesn't provide any answer within the system. And we could argue about how important revocation is, but fortunately there's a simple pattern that enables you to do revocation in the capability style. What you do is you build a proxy object, which has a single bit. Okay, and by default, that object is enabled, and all message calls are just passed through to the end target. But when you flip that bit, when you disable that object, now they're no longer passed through. And if I want to give you access to something that I think I might later want to revoke, I don't give you access directly to the end target. I give you a capability of that proxy object that I constructed on the fly. And then later, if I want to revoke, I can flip the bit. I can disable the proxy.
And what would the performance implications of that be?
Don't know. Unknown.
Nanoseconds. It depends on your system.
I think one of the philosophies of the capability approach is it would provide a bare minimum from the underlying access control system and enable you to build your own flexible abstractions on top of that. So if you want this kind of revocation, you can have it. If you want some more sophisticated kind, you can build that too. So that's why, for instance, revocation isn't a fundamental in the model, because you can build it yourself.
In the year 2012, what percentage of lines being written do you think will be written in this style?
To plus or, let's say, to 2 digits of accuracy, 0. The answer is
how about 2020?
I have no idea. Predicting the future is hard, right? You know, to first order, any new language, designing new languages is incredibly low success probability event, because there are 2 orders of magnitude more languages invented than people can actually use. Now, we hope that maybe we can improve our odds because we're working as a subset of Java. So all of your existing Java tools, all of your existing Java debuggers and development environments, you can use Joey in. But really the core of this message is not, of this talks message is not Joey. It's that you can use these ideas in any language. A language like Joey will help enforce the discipline, will help make it easier for you to be confident that you've applied the rules, but you don't need to program in Joey to get some of the benefits.
It's also useful to point out that the ideas are spreading. In that list in the second line there is a list of other languages that are being built, importing these ideas into the other places. So even if Joey doesn't take off, there's a decent chance that these ideas might take off somewhere else.
Yeah, it's a risky project, but hey, I'm an academic. I'm supposed to take risky projects.
Can you repeat that since you have the microphone?
Yes, the observation that was made was that in addition, these ideas are spreading, and it's been introduced into a whole suite of other languages and other systems, and you can find some examples of some of them, and that's an incomplete list there on the slide.
And if the question is just what percentage of code will be written in a dependency or in a capability style, we already have a lot of code at Google in Java being written in this style as a side effect of our adoption of JUICE, the dependency injection framework, to echo the comments that others made previously. The design of software to be sort of referentially transparent in terms of explicit dependencies falls naturally out of JUICE, and we're already finding security benefits as a side effect. So I think the percentage will be higher than you expect.
Great.
Any other questions? Okay, David and his group will be joining us for lunch, and after lunch, we're going to be meeting the rest of the day in Ihab. What's the name of the room? Bengui. I'm sorry. 43-1. In 43-1, 43 first floor. We've got a conference room for the rest of the day in which we're going to be doing Joey design. The purpose of this is not introductory. The purpose of this is to sort of dive into the Joey design, but anybody who wants to join us for that is welcome. And let's thank our speaker.